Good morning, class 6. Today we will start our new chapter 13, Fun with Magnets. In this, we will study about the magnets. Your science book and open page number 125, Fun with Magnets, chapter 13. Now, let's start with the chapter. Students, read with me and listen to me carefully. Paheli and Bhujo went to a place where a lot of waste material was piled into huge heaps. Something exciting was happening. A crane was moving towards the heap of junk. The long hand of the crane lowered a block over the heap. It then began to move. Guess what? Many pieces of iron junk were sticking to the block as it moved away. Figure 13.1. They had just read a very interesting book on magnets and knew immediately that there must be a magnet attached to the end of the crane that was picking up iron from the junk yard. You might have seen magnets and you have been enjoyed playing with them. Have you seen stickers that remain attached to iron surfaces like almirahs or the doors of the refrigerators? In some pin holders, the pins seem to be sticking to the holder. In some pencil boxes, the lid fits tightly when we close it, even without a locking arrangement. Such stickers, pen holders and pencil boxes have magnets fitted inside. Figure 13.2. If you have any one of these items, try to locate the magnets hidden in these. Students, I think this much is clear to all of you and there is no need to explain this. Okay. Now, you all know what is magnets. It is a substance which attracts iron towards it. Okay. So, it's a substance which has a capacity or which has a quality to attract any iron material towards it. Okay. Now, how magnets were discovered? It is said that there was a shepherd named Magnes who lived in ancient Greece. He used to take his herd of sheep and goats to the nearby mountains for grazing. He would take a stick with him to control his herd. The stick had a small piece of iron attached at one end. One day he was surprised to find that he had to pull hard to free his stick from a rock on the mountain side. Figure 13.3. Now, yes, there was a shepherd whose name was Magnes and who used to live in ancient Greece. Means he used to live in Greece and sorry, no, who lives in Greece and he used to take his herd. Herd means a group of sheep. Okay, sheep and goat. So he used to take them to the nearby mountains for grazing. So when you go for grazing, when he takes his sheep and goats for grazing, what he do? He takes a stick with him just to control his herd. Okay, and that stick had a small piece of iron attached at the one, and as Like you have seen a stick of a policeman. Okay, what happens? The ends of that stick have iron attached to it. Okay, so like that only his stick also had that irons, a small piece of iron attached to it at one end, not the both sides, at one end. Okay, what happened one day, what happens when he went for grazing? Okay, now he was there, he was surprised just to find that he had to pull hard just to free his stick from a rock on the mountain side. When he went for grazing on a mountain side, what happens? His stick got stuck to the mount to the rock, and he used a lot of force just to free his stick from that rock. Okay, now see page number 126. Being attracted by the rock. The rock was a natural magnet and it attracted the iron tip of the shepherd's stick. It is said that is how natural magnets were discovered. Such rocks were given the name magnetite, perhaps after the name of that shepherd. Magnetite contains iron. Some people believe that magnetite was first discovered at a place called Magnesia. The substances having the property of attracting iron are now known as magnets. This is how the story goes. Now, it seems that the stick was being attracted by the rock, and that rock was a natural magnet which attracts the iron tip of the shepherd's stick. Then it was said that this is how natural magnets were discovered, and this is the story behind the natural magnets discovery. Okay, now such rocks, the rocks which have this quality, they were named as magnetite. Okay, and after the name, just after the name of magnetite, as that shepherd's name was Magnes. So the rock's name then were magnetite. Okay, now that magnetite contains iron. Some people believes that this magnetite was firstly discovered at a place which is known as Magnesia. Okay, there were some pupils who believe that the magnetite was firstly discovered at Magnesia, and the substances having that property of attracting the iron, the substances which have the property of attracting iron, which have the property just to attract iron towards them, that are known as magnets. Okay, this is how the story goes, and this is the story behind the magnet. In case people now have discovered that certain rocks have the property of attracting pieces of iron, they also found that small pieces of these rocks have some special properties. They named these natural occurring material magnets later on. The process of making magnets from pieces of iron was discovered. These were known as artificial magnets. Nowadays, artificial magnets are prepared in different shapes. For example, bar magnet, horseshoe magnet, cylindrical or ball ended magnet. Figure 13.4 shows a few such magnets. Now, in any case, nowadays what happens, people, they have discovered that there are certain rocks, means there are some rocks which have the property of attracting pieces of iron. There are some rocks which have the property is to attract the pieces of iron, and they also found that some pieces of that rock have some special properties. Okay, there are some in spite of having attracting pieces of iron, they have some special properties also. Okay, and they named these natural occurring material magnets. They named these naturally occurring materials magnets. Later on, the process of making magnets. Later on, the process of converting rock into magnets, or from later on the process of making magnets from the pieces of iron was discovered, and that process, or the magnets which are obtained from this process, is known as or the magnets which are obtained from this process are known as artificial magnets. Okay, and artificial magnets are prepared in so many different shapes. They are prepared in different shapes. For example, bar magnet, cylindrical shaped magnet, ball ended magnets, or horseshoe magnet. Okay, now you can see in figure 13.4 also magnets of different shapes. Now let's see activity 1. Take a plastic or a paper cup. Fix it on a stand with the help of a clamp as shown in figure 13.5. Now place a magnet inside the cup and cover it with a paper so that the magnet is not visible. Attach a thread to a clip made of iron. Fix the other end of the thread at the base of the stand. Mind you, the trick involved here is to keep the length of the thread sufficiently short. Bring the clip nearer the base of the cup. The clip is raised in air without support like a kite. Now what you have to do in this, you have to take a plastic cup or a paper cup, and that cup you have to fix it on a stand with the help of clamp, as you can see in this picture. Okay, in figure 13.5. And after placing that cup in a stand, you have to place a magnet inside that cup, and after placing, you have to cover that cup, that plastic or paper cup, with the paper so that the magnet is not visible. Okay, then attach a thread. You have to attach a thread to a clip made of iron. Then iron clip, you have to attach a thread to an iron clip and fix the other end of the thread. Now fix that other end of the thread at the base of the stand. You have to fix the other end of the thread at the base of the stand. Okay, now you have to students, be careful about the length of the thread. You have to keep the length of that thread short. Okay, the length of a thread should not be much. Okay, now the clip is raised in air without support, and what you will see, you have to, first of all, after placing that thread to the base of the stem, you have to bring that clip near to the cup, near to the base of that cup. What you will see, you will see that the clip is raised in. It will raise up in the air without any support, just like a kite, as shown in figure 13.5. Okay, now see page number 127. Now, magnetic and non-magnetic materials. Now let's see activity 2. Let us walk in the footstep of manganese only. This time we will change the positions of the magnet and the iron. There will be a magnet at the end of our shepherd's stick. We can attach a small magnet to a hockey stick, walking stick, or a cricket wicket with the tape or some glue. Let us now go out on a manganese walk through the school playground. What does our manganese stick pick up from the school ground? What about objects in the classroom? Collect various objects of day-to-day use from your surroundings. Test these with the manganese stick. You can also take a magnet, touch these objects with it, and observe which objects stick to the magnet. Prepare a table in your notebook as shown in table 13.1 and record your observations. Look at the last column of table 13.1 and note the objects that are attracted by a magnet. Now make a list of materials from which these objects are made. Is there any material common in all the objects that were attracted by the magnet? We understand that magnet attracts certain materials, whereas some do not get attracted towards magnet. These materials which get attracted towards a magnet are magnetic. For example, iron, nickel or cobalt. The materials which are not attracted towards a magnet are non-magnetic. What materials did you find to be non-magnetic from table 13.1? Is soil a magnetic or a non-magnetic material? Now, first of all, what are magnetic materials and what are non-magnetic materials? Magnetic materials are those materials which get attracted towards a magnet. That are magnetic materials. For example, iron, cobalt, nickel. And the materials which are not attracted towards a magnet, they are non-magnetic, like plastic, paper, scale, leather. Sorry, scale is made up of plastic only. Leather, okay, cloth. So that are non-magnetic. Students, in this activity too, what you have to do, you have to take a stick, and in that stick you have to stick a magnet in that, and you have to found the magnetic substances or the magnetic minerals in the soil. Okay. Now turn to the page number 128. Activity 2. What you have to do? You have to take a stick and stick. In that stick, you have to stuck a magnet with or attach a magnet to that stick. Okay, and from that stick, you have to find the magnetic materials around you. Okay, now let's see activity 3. Rub a magnet in the sand or soil. Pull out the magnet. Are there some particles of sand or soil sticking to the magnet? Now gently shake the magnet to remove the particles of sand or soil. Are some particles still sticking to it? These might be small pieces of iron fillings picked up from the soil. Through such an activity, we can find out whether the soil or sand from a given place contains particles that have iron. Try this activity near your home, school, or the places you visit on your holidays. Does the magnet with iron fillings sticking to it look like any one of those shown in figure 13.6? Make a table of what you find. Like table 13.2. Okay. Now in activity 3, what you have to do? You have to rub a magnet in the sand or a soil, and after rubbing you have to pull that magnet out and see that some particles of sand or soil are sticking to that magnet or not. Okay, and if you find some particles, what you have to do? You have to shake that magnet just to remove the particles of sand or soil. Then also there are some particles which will there will be some particles which will still stuck to it. There will be some particles which will stuck to it after shaking that magnet. Okay, now the particles which will still stick to that magnet, they will be the small pieces of iron, which is known as iron fillings. Okay, picked from the soil. Now through this activity, what you have to do? You have we can find out that whether the soil or a sand from a given place or from our surrounding contains the iron fillings or not. Okay, we can try this activity near our home, near our school, at the park where we go for walk or playing, or the places where we visit for our holidays. Okay, now then what you have to observe? You have to observe that any of the magnet with iron fillings does match with the pictures or the magnets as shown in figure 13.6. Okay, now the A1 is a magnet with more iron fillings or many iron fillings. The B1 is few iron fillings, and the third C is no iron fillings sticking to it. You will find this table and send it to if you fill this table and send it to Paheli and Bhujo, they can compare the amount of iron fillings found in soil from different parts of the country. They can share this information with you. And if you found it, then just try to compare it. Okay, that which place is having more iron particles. Okay. Now 13.2 poles of magnet. We observed that iron fillings, if they are present, stick to a magnet rubbed in the soil. Did you observe anything special about the way they stick to the magnet? Yes, I observed. Yes, I observed. The stickings or the particles that stick at the ends only. They get stuck at the ends of the magnet only. Why? Because there are poles of magnet, or the magnet have two poles which are known as the north pole as well as south pole. There are two poles of magnet, north pole and south pole. Okay. So the iron will get stick to the poles only. Okay. Now see activity 4. Spread some iron fillings on a sheet of paper. Now place a bar magnet on this sheet. What do you observe? Do the iron fillings stick all over the magnet? Do you observe that more iron fillings get attracted to some parts of the magnet than others? Remove the iron fillings sticking to the magnet and repeat the activity. Do you observe any change in the pattern with which the iron fillings get attracted by different parts of the magnet? You can do this activity using pins on iron nails in place of iron fillings. Draw a diagram to show the way of filling stick to the magnet. Is your drawing similar to that shown in figure 13.6a? We find that iron fillings are attracted more towards the region close to two ends of a bar magnet. Now, as I told you that a magnet has poles, the north pole and the south pole, and the iron, okay, or the attracting property at these poles is more in comparison to any other region of a magnet. Okay, the poles have more attracting property in according to or in comparison to the other region of the magnet. Okay, in this activity what you have to do, you have to spread some iron fillings on a sheet of paper and place a bar magnet on that. What you will observe? You will observe that the iron fillings will get stick. That many of the iron fillings get stick to the poles rather than the other region of the magnet. Okay. And after that you have to remove that iron fillings and again repeat this activity. What you will observe? That the attracting property is same or the pattern will not change. Okay. Now see page number 129. Said to be near these ends. Now the poles, as I told you that a magnet has two poles, which is north pole and south pole, and they are present at the ends of a bar magnet. Okay. Now try and bring a few magnets of different shapes to the classroom. Check for the location of the poles on these magnets. Use iron fillings. You can now mark the location of poles in the kind of magnets shown in figure 13.4. Now students, 13.3 finding directions and 13.4 make your own magnet. 13.5 attraction and repulsion between magnets we will discuss in our next class. Revise the taught portion, and if you have any problem then ask me. Thank you, class.